Alright, in this video I'm going to talk about phases of the waves, the graphs of sine functions, and phase difference, and whether two waves are in phase or out of phase. So this is something that has applications in physics and in some engineering stuff as well. Whether two waves or two sine functions are in phase or out of phase. Alright, so first off, we have two equivalent forms of sine curves. We have y equals a times sine of kt minus b, and here when our sine function is in this form, that b that's there is what we call the phase of that sine function. Right? So that's our phase. An equivalent form, y equals a times sine of, factor out the k, so k times t minus b over k. Here that b over k is our horizontal shift. And this should look somewhat familiar. If you looked at the videos I did about the graphs of the sine function, the a is the amplitude, the k, the number that's multiplying the t but like factored out of it, that determines the period of the function, and then the number added or subtracted from the variable is your horizontal shift, right? And if you're not sure that these two are equivalent forms, start with the second one. If you just distribute that k into the parentheses here, you get k times t, which we had up here. When you do k times b over k, the k's cancel out, you just get minus b, which is also what you had up there. Right? So that's a quick way to just confirm that those two are equivalent forms of a sine curve. All right, now when we're talking about graphing sine functions, we had things in this form, so we can do our horizontal shifts and find our period and all that stuff. But if we have it in this form here, then that number b is what we call the phase of our sine curve. All right, so now we're not really concerned with the phase of any single sine curve. What we're concerned with is comparing two different sine curves and finding the difference in their phases, which we call the phase difference. Pretty commonplace, self-explanatory definition there. So y1 is a times sine of kt minus b, right? So it's in this form up here, where the k is inside the parentheses with the t and the b. And then y2 equals a times sine of kt minus c, right? So notice the similarities between those two curves. First, they both have a, right? So they both have the same amplitude, right? If two sine curves do not have the same amplitude, then we're not going to be concerned about their phase difference and if they're in phase or out of phase. We're only concerned about that if they have the same amplitude to begin with, right? So that number in front of the sine has to be the same for each one that we're comparing. The k, the number that's multiplying the t, also is the same thing, right? So those two numbers, the a and the k, have to be the same. What can be different is the phase itself. So this one has a phase of b, and the one over here has a phase of c, right? So the phases can be different. And then to find the phase difference between y1 and y2, it's b minus c, right? So the phase of this one is b, the phase of that one is c. If I subtract b minus c, that gives me the phase difference. Again, it makes sense if you know what the phase is. Difference is the subtraction, the difference between the two by subtracting. All right, so if our phase difference is a multiple of 2 pi, that means that our waves are in phase. All right? If it's not a multiple of 2 pi, then they're out of phase. All right, so that's what we mean by two waves being in phase or out of phase. They have to have the same amplitudes, the same k value there, and then if the difference in their phases is a multiple of 2 pi, we say they're in phase. And if two sine curves are in phase, then when you graph the two of them, the graphs completely overlap each other. It's basically the same graph, right? And the reason that is because if you recall, for the sine function, the period of the sine function is 2 pi. Right, so it takes 2 pi to do one full cycle, like all the way up, all the way down and back, and then 2 pi, it does it again. So if the phase difference is a difference of 2 pi, they might be offset from each other, but if they're offset by a multiple of 2 pi, well, they still overlap each other, right? And I'll be doing an example on another video where I actually go through and do that and show you what that looks like, right? But this is just the definitions of phase and phase difference, whether things are in phase or out of phase. So that's what we got here. Look for that other video that I'm about to do where I go through an example. I would do it all on this video here, but I'm not sure if the example is going to fit on the length of time we have left in this video. So I'm going to start a new video and just do that example there where we use some of this stuff and find the phase difference between different waves and look at the graphs and see what those look like. So make sure you check out that other video I'm about to do.